So once again, my name is Sammy. I'm the Donor Engagement Coordinator here at Hawkwatch, and today you are here for one of our virtual Lunch and Learn series, Take a Bite Out of Science. And today we're going to be talking about why birds migrate. So the point of the Take a Bite Out of Science lecture series is to take science and then make it a little bit more digestible for everybody in these short form lectures. So we are able to host these lectures for free thanks to Salt Lake County ZAP funding and then also the generous support from donors like you. So I'm going to pass it over to Jesse Watson, our research biologist and banding coordinator. So Jesse, you want to take it away?
Sounds good. Thanks, Sammy. All right. Hi, folks. We'll talk about migration today, which is timely because birds are going to be beginning to migrate here in the next few weeks. So first off, if you've never heard about Hawkwatch International or been to one of our talks or a lunch and learn, our mission is to conserve the environment through education, long-term monitoring, and scientific research on raptors as indicators of ecosystem health. This is a red-tailed hawk here. And a lot of the work that I do is focused on migration-related research and monitoring of this long-term monitoring of raptors as they migrate each fall and spring. So starting off just kind of basic, talking about what migration actually is. Here's some nice images of various animal species doing some sort of migration, and there's lots of different types of migration, like very long distance, as in thousands of kilometers. There could be a shorter migration of just a few kilometers. Imagine if you're a very small species and you're not going very far, at least in human terms. You know, if you're still moving, say, a kilometer or 500 feet or whatever that is, that could be a pretty good distance for that animal. Elephants, I was actually reading about them. Their migration is typically, or in some cases, like 60, 70 miles. So I'm sure some go farther and shorter than that, but different than some of the birds we're going to talk about that are going, as we said, thousands of miles. So you've got some caribou up here and some sea turtles down at the bottom. When you think about migration, I often think about, of course, birds, but butterflies. You think about monarch butterflies doing their famous migration. Now we've got salmon migrating up streams to spawn or out to the ocean. And we've got some geese, kind of a classic formation there migrating. And so a kind of a formal definition of what migration is the regular seasonal movements from breeding areas to resting grounds and back. And there's probably lots of different definitions, but I think that's a fairly succinct one that kind of applies to what we'll be talking about. So the next question is, why do some animals migrate? And when I'm starting broad with animals, but I'm going to really focus on birds, of course, as you probably suspected. So why do some animals migrate? And obviously the way I worded that makes you realize that not all animals migrate. And so these animals are moving because of their search for resources, right? They're after food and shelter, just like any other animal. They need those things to survive. If food is not limited and they don't have a reason to migrate, they probably won't. They're comfortable staying in one area, and typically that's when an animal is sticking around in one spot or not moving very much. That's associated with the conditions, the environmental conditions, because it's not that harsh of an environment. You think about a place like, say, Florida, or in some cases even Utah is an example that we'll talk about. For some animals, the environment is mild enough that they can make a living, so to speak, year-round without having to leave. So a good example are hummingbirds. We all hopefully love hummingbirds, and humans often will put out hummingbird feeders, and we know that that'll attract these birds. They'll fuel up, and then we typically, depending on where you live, will see those hummingbirds leave in the off season because despite the fact, say if you're in a northern environment and you have hummingbird feeders out, most of the flowers are dying and the natural food sources have left. So the birds kind of have to track those. They go south in the fall to more less harsh environment. And birds or animals are also leaving and migrating because of energetically challenging conditions. So it's getting cold. Uh, if you're a bird or an animal very far north in Alaska, and it's getting cold, not only is the food not there, but it's just a hard environment to live in. And so we see birds moving south. And so this is a Cooper's hawk here that's maybe actually sticking around in the winter at someone's bird feeder, maybe sticking around longer than they would if there wasn't a food source. So in this case, these folks at this house have bird feeders out. They're feeding sparrows or something like that. And this Cooper's hawk is happy to stop by and replenish its food source. So whether this was on migration or further south, it's hard to know. But then the question is begged, what about the other animals, the ones that don't migrate? Or how has how have changes to the environment affected those animals um, and affected their migrations? Are animal migrations changing? So I have a picture of American kestrel here, and this is just one example again of an animal that in all cases doesn't migrate, depending on where that animal is living. So here we have a map, and basically, without having it be overwhelming, this is an abundance map. So the colors indicate where American kestrels are in the northern and southern hemispheres, North and South America, Central America. Uh, the abundance, relative abundance, is here, and a darker blue means a higher abundance. And then we have a calendar, basically, that goes through all the months, and we can see how the abundance of the American kestrel changes over time. So we're going to watch a quick video. We might watch it a few times here, but just watch how middle of the summer the birds are going further north. We've got some up in Alaska, and mostly we're looking at the northern hemisphere here, and things change. And so now we'll watch it again and watch the circle, which is focused on the state of Utah, just because that's where I'm speaking from. You can see that in December, January, there are American kestrels here. And you kind of watch this little circle. The abundance changes a little bit. There's maybe a little more in the summer. Birds migrating through and back to winter. So a lot's going on there. But the main thing I want you to take from this is at this latitude, which is, it's not at the equator. The equator is down here, but it's fairly mild, especially compared to, say, Alaska. So we see in the winter, there's no American kestrels up this far north, but there are some here. And we know from our local studies in Utah that many of our birds, as in American kestrels, do actually stick around throughout the year. They might move short distances, several miles across the valley, but that's not a real long distance migration like you're seeing from these birds in Alaska. In fact, I don't have a map here, but we actually tagged a breeding American kestrel in Alberta during the summer, and that bird migrated all the way down to Nicaragua and back. Meanwhile, that bird was passing over kestrels that maybe winter and spend the whole year in Utah. And so all of that is driven by all these different conditions in the environment, and those cues that are influencing these birds to move or not to move. So that leads into variability in the environment, and first kind of thinking about seasonal timing. So these now we're talking. We've already established that not all of these animals are migrating, but then I want to talk just a little bit about how migration and migration strategies for some of these individuals and animals can be changing, and some of that is changing due to unpredictability in the environment, and a lot of what I'm going to talk about here are associated with changes in the climate. So a warming climate has resulted in changes in timing. If you think about when the flowers are blooming or when things are occurring, if it's warmer, those things might be occurring earlier in the season, and there's trickle down effects from that that can change when an animal needs to move. And if they're somewhat making a gamble, if they're assuming I need to be 2,000 kilometers north at this time to hit the the bloom of when this thing is here, or when uh, you know when the flowers are all blooming and I need to get my nectar. If they're planning on that and then that window is off by 2 weeks and it's still snowy, or they miss it, you can imagine how that impacts them significantly. So thinking about seasonal timing, and I'm just going to show some titles from papers that have come out looking at how things have changed. And really, what we're looking at here is phenology. Phenology is the study of cyclic and seasonal natural phenomena and how they change in relation to climate and plant and animal life. And so each of these animals, the American kestrel, has a phenology throughout the year, and that is changing due to things that are happening in the environment. And there's lots of different studies showing that bird movements, and not only limited to birds, but of course we're focusing on birds here. There's studies showing that changes to the environment, a lot of them driven by differences and changes in the climate and timing throughout the season, um, have affected where the distributions of these birds are. And if you imagine American kestrel that's right on, say, the fringe of an area that they can survive year round because it has enough food, if the climate warms a little bit, or the general temperature throughout the year is warm enough to maintain their food source and allow them to survive in that area, what we're seeing generally is the further north latitudes have a warmer environment more consistently throughout the year. So if you're one that was formerly at a latitude that was cold, maybe that shifted a bit and now it's warm enough for you to continue living uh, and not have to migrate. Or maybe you still migrate, but your timing has changed by a couple weeks. So you can see how changes to the environment may be affecting when these birds are moving and how they're moving, and maybe how far they have to go. Now, the other thing that's unpredictable, I guess timing is somewhat unpredictable, but the other challenge for these animals that they're battling with and gambling with are extreme weather events. And unfortunately, again, with a more unstable climate, there's more extreme weather events. You think about Texas last year with extreme cold snaps. There's more strange events like that that are happening, whether that's snowstorms in the winter, or sorry, snowstorms in the summer, or vice versa, really warm in the winter. And so this actually was a study that I was part of in my ferruginous hawk research. And this wasn't necessarily a negative or positive response, but we saw ferruginous hawks based on extreme weather events, so big snow or big rainstorms and those types of things. The actual adults had their behaviors altered. So when they were actually seeing experiencing these extreme weather events, and they were building up their nests, so bringing more sticks to the nests and preparing for those events, which is really interesting behavior and pretty fascinating. But on a more serious level, extreme weather events can be negative, can result in loss of animals. So burrowing owls, for example, with more extreme spring rainfall, that has caused this second paper is about burrowing owls, and that has caused, as you can imagine, if you're a burrowing owl nesting in a burrow and there's a lot of water, that's going to cause problems for you if you're breeding there. And there is generally more spring precipitation with changes in the environment over the last decades. And then there are weather-related mass mortality events with migratory birds and other animals, and that's happening. It has always probably happened. There's just freak storms and things that happen. You imagine you're a bird or a big group of birds, and last year there was actually quite a few stories about this in certain areas where there would be swallows. I think New Mexico had um, cases where there was a bunch of swallows that got caught down there, and they weren't there at a good time, and there was a weather event, and it affected them and killed them. If there's cold that comes in and kills all the bugs that these individuals are feeding on or something like that, that's hard to predict and can affect these birds. So one topic that's probably close to home for a lot of us in the West is the fires and the smoke. And so this is just an image from the NOAA Weather Service of smoke last year, and we get a lot of questions about how does this weather and the smoke affect birds that are migrating. And we don't really fully know the answer, but we do know that it's an additional challenge for these individuals on top of everything that we just talked about. Excuse me. So with smoke, things are a lot more dry, things are hot, and it's obviously challenging if your food sources are dying or getting pushed around by that smoke. And so just lots of challenges out there for these animals. Okay, so moving away from some of that, I guess, negative feeling stuff as far as birds having challenges, let's just talk briefly about how these birds migrate. And this will kind of feed into the work that we're doing now with raptor migration. So birds are using geographic features, mountain ranges, coasts, water bodies, to facilitate their movement north and south. Birds have actually been shown to observe the stars and to look at the North Star, for example, and know how to migrate at night looking at the star, which is pretty fascinating and amazing. Um, Magnetic cues. There's been some research to show if you put a bird in like a little structure like this during different seasons and put some ink on their toes, really rudimentary, but pretty fascinating. The bird will try to jump and travel in the direction that they should be going during that part of the season, and that's related to those magnetic cues that they inherently have built in. There's smell, sound, uh, lots of different cues that are helping these individuals migrating. And I'm sure one that's not listed here is probably watching other individuals from the same species. I'm sure there's a lot of actual learning that goes on just by observation. So specifically thinking about raptors and their migration, they I don't like to say that they're lazy, but they're efficient and smart. They don't want to spend more energy than they need to migrate. And so to accomplish that, they will use wind, they will use thermals and ridges and geographic features to minimize their effort. And so if you watch this northern harrier, you've got wind that's coming in from the left side, it's hitting that ridge, and what's it do? It pushes the harrier up in the sky. And that allows them to use less energy. They're not flapping a lot, and they're moving right along and pushing on. We also talk about thermals. And if you've never seen a thermal, it's pretty fascinating. Basically, there's warm air currents. We all know that warm air rises, and the air is generally circling up and kettling up. And these birds will come and they'll find those thermals, they'll open their wings, and it essentially just pushes them up into the sky. And again, like that prevents them from having to use a lot of energy, which is efficient. And so then what they'll do is they'll open their wings and they'll glide to the next spot, the next thermal, and they'll do the same thing. They'll circle back up and then they'll glide to the next one. So really efficient method for traveling long distances. So here's a kettle of broad-winged hawks. This is from Corpus Christi in Texas at one of our hawk migration sites, the Corpus Christi Hawk Watch, which is actually beginning to count raptors here in 3 days on the 1st of August. That's when the count starts. And they're going to start looking for birds that are coming from the north and doing this and moving south. And so broad-winged hawk migration is pretty spectacular. They're one specific species that travels in very large groups, typically, like this. And so it's a pretty spectacular phenomenon to see. And here's an example of what I was describing. So if you tried to count all these birds right here, it would be overwhelming, extremely difficult. It just looks like a bunch of mosquitoes. Um, but what they do is they kettle up, get to the top, and then they set their wings and they travel south, and then they just glide out in one direction. And so that's what they're doing here. You can see their tails are on the right and their heads are on the left. They've all got their wings set and they're just gliding. And so once they pass this plane essentially in the sky, they're not going to come back. So you can basically set a spot that you want to watch and count them as they're moving by. And there may be thousands or hundreds of thousands depending on how good the flight is and how good the conditions are. So I just wanted to add a few maps from work that I've been involved with. Not only can we learn about these birds' migration from a Hawkwatch site where we're actually observing them physically migrate by, the other things that we can do is tag these birds with satellite transmitters, and we can track them. Um, so it's a much smaller number of birds because it's difficult to tag them, but we get very accurate, precise, and fascinating information by tagging a few individuals and seeing exactly where they go. So this is not this image, the bird itself in that picture, but the map here. We tagged three broad-winged hawks that were breeding in Alberta, and you can see they migrated through. They actually migrated through Corpus Christi, which is in the background here, right at this location, and they migrated down to Bolivia and different areas down in South America. And so that's another method for tracking migration. Now, another thing, I guess, getting towards our Hawkwatch sites, thinking about why we chose those sites to monitor raptor migration. It's about the landscape. So I like this image here, just to orient you. If you're not familiar with Salt Lake, it's right here, and we've got a huge mountain range right here, very tall. You think about all the ski resorts in Utah, um, they're up on this range right here. And the reason that the snow is actually really good is because you have the Great Salt Lake here. And so a lot of the water comes off, it comes off the lake, precipitates, and it drops on those mountaintops. Now, if you're a bird moving south, so here's Utah, this square, and we've got Nevada over to the left. If you're moving south, there's not a lot of topography in this area. It's just a big, flat salt desert. So it's not a fun place to migrate through. You don't want to fly there. What you want to do is find one of those ridges, like we saw with that northern harrier, and minimize your effort. And so what we know is sitting on or spending time at these locations along these ridges are the hot spots to really find birds that are migrating. So there's a really good spot in the Wasatch to watch raptors migrate by. We don't currently count at the Wellsville Mountains anymore. We used to. But the site I'll highlight here is the Goshoot Mountains, which is in Nevada, but it's the same effect. Salt Lake in the desert is to the east of the Goshoots. This huge open expanse is there, and the first mountain range in Nevada is along this range. And so these birds, if you watch them, they're these orange birds at the top. They're going to migrate down, and they're going to filter right through those areas. And so we can basically set up at those spots, and we can see and plan on seeing these raptors come through. So here's an image of the sites where we currently monitor raptor migration and a timeline to show you how long we've been doing that. At some sites, it's been longer than I've been alive, early 80s. And these are the sites that we'll be counting and monitoring raptor migration this fall. And here's the Goshoot Mountains that we just highlighted in Corpus Christi down here. So briefly, what does it take to monitor migrating raptors? We have a crew of about 5 individuals at each of those sites, and they're all probably getting pretty excited right now to begin doing this raptor migration monitoring here in the next few weeks or month. This is what a typical view may look like. So we've got a lot of landmarks. You're scanning the sky, you're looking north, at least in the fall, because you're looking north to see birds moving south. It takes a lot of patience, endurance, obviously binoculars and ID skills. I like this comment, a little bit of crazy with a dash of hermit. These crews are typically camping out on these ridge tops for 2 to 3 months, but it's a very fun experience and exciting. And these sites are all open to the public. And so, we are being cautious with the virus and everything. Good thing is we're outdoors, but you can visit all of these sites because they're all on some sort of public land, whether that's Forest Service or BLM or something like that. So we encourage you to do that if you're in the area and interested. So just a few more examples and then we'll wrap up. I wanted to show some cool migration maps of a few different species here. And we've got a Swainson's hawk. You'll be familiar with this map. It's the same as the American Kestrel. But Swainson's hawks, as a rule, there are a few exceptions, of course, but generally they are a long distance migrant. And so we've got little Hawkwatch sites here to show you where our sites are that you're familiar with now. But you can see this is in the spring. The birds are moving north. So we'll pause it right here. So let's say right here is when the birds are breeding, Swainson's hawks. And now, go to right there. This is July. This is where all the Swainson's hawks are. Pretty soon here, they're going to start filtering south. Swainson's hawks are known to generally migrate to Argentina in winter there and then migrate back year after year after year. So if we're at those migration sites that we just listed, we should be able to capture and count and identify many thousands of those birds coming through. Oops. Let's watch the video again. So here, right here is current, right there. Watch them start to filter south. And the Swainson's hawks are all gone. And then they'll come back in the spring. I couldn't get through this talk without mentioning the ferruginous hawk. Again, we see where the hawkwatch sites are on this map. The thing that's different about these birds and some other species is they generally are located in open grassland habitat. So they don't often migrate, or as a rule, they don't always migrate along mountain ridges like a lot of these other birds we've talked about in the West. And so they're very difficult to count at ridgetop sites. We see a few of them, but if you watch this map, we don't have any sites in these areas where these birds are moving. And so they're much more sporadically observed at our migration sites, which makes them a tough individual to learn about their migration. And they also, compared to Swainson's hawks, aren't migrating nearly as far. So here's a ferruginous hawk, and just another map using satellite telemetry. This was part of my master's research. And here's Alberta up here where I was tagging these birds with satellite transmitters. And then you can see exactly where they went with their tracking data. And notice, here's the Rocky Mountains here. Most of them stayed east of those and were out in the plains in these open areas. So pretty cool information that we can learn about migration through using technology. Okay, I think I'm to my last one or two slides here. So just an invitation to circle back to this, to if you're interested in migration. If you have any questions, you can write us at migration@hawkwatch.org. I recommend checking out our website here. I think Sammy might have shared the link in the chat about our migration sites, and we've got all the sites listed here that will be operating. You can read about when they're open and get details about how to get there and what the highlights may be at those sites. So we encourage you to check that out. And if you are not located in the West, say you're out east or somewhere outside of the area where we're counting and monitoring raptor migration, check out this website, popcountorg. You can actually go to this website, click on this map, and then find your province or state, and it will list any hawk watches that are in your area. So you can read up on those and get in touch with folks, see if they're operating, and go check it out. Also, this website displays live data. So assuming the sites, and we do this at Hawkwatch International, assuming the sites are uploading their data daily, you can kind of keep up with the count and see like, oh, this is how many birds they're seeing right now, which can kind of help you prepare to visit if you plan to do that. And that is it. So I think we stayed pretty close to on time. I might have got a minute over, but yeah, happy to answer any questions.
Alrighty, so thank you, Jesse. So we have a few questions for you. I'll keep it snappy. So, first question. Are migratory species that set up territories better or worse at establishing and holding those territories, or would this depend on resident species?
So a migratory species, do you mind reading it again? Sorry.
Sure. Are migratory species, those that set up territories, better or worse at establishing and holding those territories, or would this depend on the species?
So I assume that's relative to species that are not migratory.
Mm-hmm.
Yeah, it's a good question. I mean, there's competition for sure. Like if you're a Swainson's hawk, for example, competing with a ferruginous hawk to nest, from one year to the next, you may see one or the other of those species use that nest. In that particular example, Swainson's hawks arrive later than ferruginous hawks do. and so the Phrygian hawk is going to get the priority. Um, but that doesn't, as long as they're not limited by, they don't need to return to the same territory as a rule to succeed. So they're pretty adaptable, and that's probably fair to apply that logic to most of these species. Like they can go and set up shop, so to speak, put a nest up in wherever they need to and be successful with some limitations. So I don't think there's a clear answer, unfortunately, but it's a good question for sure.
All right, next question. How far can a raptor migrate in a single day?
Ooh, that's a good one. Really driven by the conditions and the species. So I've these ferruginous hawks, for example, that I've tracked. I've seen them travel several hundred kilometers easily in a day. You know, 300, 400, uh, several hundred plus. Um, if they have prevailing winds that are pushing them and the conditions are good, they can really cover a lot of ground. They could probably migrate 30, 40 plus miles an hour. That doesn't mean they're always traveling that fast. Um, but yeah, and sometimes they'll hold out if the conditions are bad, and they'll wait for those good conditions to show up, and then really, essentially, it's like dropping in on a racetrack, if you want to think of it that way. Like, okay, things are good, and then they go and they wait until things are good again.
Cool. Okay, and then our last question is, do hatchier birds follow their parents on their first migration journey?
Yeah, that's a good one. I think the probably the answer is no. Uh, it's an extremely challenging question to really have data to answer. I'm not aware of anybody that actually has that information. I guess folks have definitely tagged hatchier birds and their parents probably, but I don't think they're traveling together. Generally, at least with raptors, generally after the birds have fledged and are flying on their own, and there's some exceptions. You think about like a martial eagle, for example, they're with their adults for like a couple of years, I believe. But these birds in North America that we're talking about, even golden eagles, a huge, huge bird. Like once they are on their own hunting, I think they're kind of on their own. They might see their parent again, but they're not depending on them to follow them to migrate. And that's where I was getting at when I kind of mentioned I think they're probably so observational that they can just get up in the sky, they can see 2 miles ahead or whatever, and see, oh, there's another golden eagle, and it's flying overhead and it's migrating south. So they're pretty perceptive, if that's the right word, in figuring that out.
All right, really quick, one last question we just got in.
Yeah.
In regards to red tails, since there are so many different morphs, do they tend to travel together or separately?
Oop, sorry, I don't know if it's my internet. Something got choppy.
Oh, I was
So in
asking
regards to,
for red tail hawks, because
yeah,
there are so many different morphs, do they tend to travel together or separately?
yeah, that's an interesting question. The reality is that there's just as many morphs with many of the Bootios species. So rough-legged hawk, ferruginous hawk, Swainson's hawk, um, red-tailed hawk are just there maybe is a bigger spectrum, but they're much more abundant. So I don't think there's any evidence to suggest that they're moving in groups color coordinated, or plumage with plumage associations. The logic there would be regionally, there's probably, or we know that there's certain morphs regionally that they're more likely to be in an area. Like in the West, for example, there's more dark birds and there's very few in the East, if any. And so because of that, like you might look at that and say like, yeah, they're traveling together, but really it's just because they originated in that area. They're not actually chasing each other.
Got it. Well, thank you for fielding the questions, Jesse, and thank you all for attending Take a Bite Out of Science. So we do have another lecture coming up in August. It's a little bit more long form, and we're speaking with a raptor biologist who helped reintroduce the peregrines back to the state of Utah. So that should be a good one. But yeah, thank you again for attending.
Thanks, everybody.